Okay, this is the January 2021 paper. It's question number 6, and this is an integration question. In particular, we're going to be finding the area under a curve which has been defined parametrically, but we'll have some integration techniques in there and some other parametric versions. Okay, let's have a look at this question then and just see exactly what we've got to do. So it says, the curve is defined by x equals 2 cos 2t and y equals 4 sine t, and it's done between those limits there. And what they're asking us to do is to find the region R, show the region R is given by this integral here. Okay, so let's make a start on that one then, part A. So hopefully you're aware of the fact that if we want to find the area, that's simply going to be the integral of y dx. So it's the integral of y dx between 0 and, let's just call this value here x1, between 0 and x1. So that's what I'm trying to do, but I've got my version parametrically. So what I'm going to have to do is to say, instead of saying y dx, I'm going to say y dx dt. So I'll actually be integrating it with respect to dt. So that means that these limits here are going to be t's. So I'll call it t1 and t2. And I've now got lots of different things that I need to work out. I need to work out what t1 is. That's going to be when x equals 0. I need to work out what t2 is. That's going to be when x equals x1, or we'll find values for what they're going to be. Once I've done those, I'm going to need to work out dx dt and y, and then put everything into the formula. So let's have a look at the limits first of all. There's lots of different ways we can do this. I'm going to say limits, and because I've labelled it like this, I can say, right, okay, for t2. So t2 is going to be that value there, and t2, I know it's when x equals x1, that's no good to me. I know that's when y equals 0. Okay, so because I've got x and y is parametrically defined, that's the most sensible thing to do. For t2, y is going to be equal to 0, and remember y is 4 sine t. So I'm going to get 4 sine t equals 0, which gives me sine t equals 0, which gives me that t is just equal to 0. Remember, we've got t being between 0 and pi over 2 there. Okay, let's see if I can find t1. So for t1, that's going to be this one here, and that's simply going to be when x equals 0 this time. So for t1, x is going to be equal to 0, and if x is equal to 0, that means 2 cos 2t equals 0, which means 2t would work out to be 90 degrees, or we're doing it in radians, would work out to be pi over 2, cos 90 is 0, cos pi over 2 is 0. And if that's true, then t is going to be pi over 4. And again, both of these values now then are within the range that I need. Okay, so if I'm going back here, I've got this one, I've got this one. I know what y is 4 sine t, but I've also got to find dx by dt in here. Let's just tie this up, I'll get rid of all that nonsense. So if I have that x is equal to 2 cos 2t, then dx by dt, differentiating that, the differential of cos is minus sine. Because we've got the 2 here, this is going to work out to be minus 4 sine 2t. If you're having difficulties doing something like that, you need to go back and do a little bit more work before you look at past papers. So what did I say? I said that r was going to be equal to the integral between t2 and t1 of y dx dt, and I can now substitute values in here. So I've got t2 was 0, t1 was pi over, t1 is pi over 4, t2 is 0. I've got y, which is 4 sine t, and then I've got dx by dt, which we've now said is minus 4 sine 2t dt. So all I now need to do is to tidy that up and make it look like the answer that we've got here. Well, you should know that sine 2x is 2 sine x cos x. So we can now get that that part there is between 0 and pi over 4. I've got 4 sine t times minus 8 sine t, not 2t, sorry, sine t cos t. Now be careful the way you write that down, because it might look like it was actually being subtracted there. Be aware of the fact that I'm going to get rid of that minus by flipping these limits, okay? If it's 0 to pi over 4 there, that's the same as pi over 4 and 0, and just flip the limits, flip the limits and get rid of the negative, and I've got 4 times that, I've got 32, I've got sine squared t, I've got cos t dt. I'm pretty sure that's actually what we were trying to prove. Yeah, that's what we were trying to prove up there. I didn't, but it's always a good idea to keep checking back to see that you're on the right lines there. But I was pretty confident as I was going through and doing that. So that's part A, part 1, whatever it's called. Yeah, A part 1 done. A part 2, can we now actually do this? Can we now actually integrate it to find what the integral of that's going to be? So what we've got for the integral, I've got the integral between pi over 4 and 0 of 32 sine squared t cos t dt. So this is relying on what some people call the reverse chain rule. One way of looking at it is to think I've got a function to the power of something, okay, and then I've got the differential of that function alongside it. So here we've got sine squared, and the differential of sine is cos. So this is a perfect one to try and do using the reverse chain rule. And the way that I do it is I say, okay, if I've ended up with sine squared cos, I'm going to guess what I think my answer might have been for the integral. So the sensible guess would be, let's assume that it was actually sine cubed t. Why would I think that? Because when I differentiate, and differentiate this quickly now, P4 exam, differentiating that becomes the differential of a cubic, sine cubed becomes 3 sine squared, multiplied by the differential of what's in there, multiplied by cos. Yeah, we're getting the same sort of format that I've got for my integral. So I know the integral of this, the integral of this would be that. I haven't got the integral of 3 sine squared cos t, I've got the integral of 32 sine squared cos t. So we can now say, really simply, that the integral in pi over 4 and 0 of 32 sine squared t cos t is equal to 32 over 3 sine cubed t. And all of that then between pi over 4 and 0. It's up to you as to how much work you want to now show with this. Well, obviously we're going to be putting in, so 32 over 3 outside, we're going to be putting in sine cubed pi over 4 minus sine cubed 0. In terms of keeping the video quite brief here, that just works out to be 8 root 2 over 3. That's the exact value then for R. Let's go back and look at the rest of the question. As I say, it's a long question, so I didn't want to spend too long just going through and doing that part. Part B then says, show that all the points satisfy this equation here. So what that's really saying is, can I write the parametric equation in a Cartesian format? So yeah, absolutely I can. Let's just crack on and get started with doing that. So for B, I've got that x is equal to 2 cos 2t, and I had previously that y is equal to 4 sine t, and now what I want is an identity that connects cos 2t and sine t, and hopefully you remember that from when we were doing our work. Cos 2t is equal to 1 minus 2 sine squared t. So all I'm now going to do is, if I'm using that one, is say, okay, if I want to get cos 2t, cos 2t is just x over 2. Sine t is just y over 4, so I can sub all of that in. X over 2, cos 2t, is equal to 1 minus 2 y over 4 squared, and now I just need to tidy this all up. So we get x over 2 is equal to 1 minus, what's that, y squared over 8 there. Multiply everything out. If you multiply everything by 8, I'm going to get 4x is equal to 8 minus y squared. So I'm going to get y squared equals 8 minus 4x. So I'm going to get y is equal to the square root of 8 minus 4x. So B, getting it to look like that. Yeah, I've done that and I've worked out what A and B are. And then the last part, part C, finding the range of this. We can go back. I've got C down there, but that's handy. Let's put it up here. So if I want to do the range of the function, I can see that the range of my values is just from there to there, isn't it? Okay, so it's just from there to there. If I'm going to do that, it's only worth 1 mark for this, so it needs to be nice and quick when we're doing it. I've got that y is equal to 4 sine t. Those are my y values. So if I put t equals 0 in, I get y equals 4 sine 0, or in other words 0. I could have seen that from the graph anyway. If I put t equals pi over 2 in, which was the other extreme, I get y equals 4 sine pi over 2, which works out to be 4. So we can say the range of values is f from 0 to 4. Okay, hopefully that all makes sense.